Here is a function generator and a DC power supply. The function generator is on the top. The frequency has set to be 10 kHz, and the peak-to-peak voltage has set to be 200 mV. Now let's take a look at the DC power supply. This DC power supply has two outputs. We use the first one, that is channel 1, and is set to be 20 volt. Now let's turn on the function generator to enable the AC source. The AC source signal is shown here, but the peak-to-peak voltage is not 200 mV, it is 140 mV. We have to adjust the function generator so it can provide the expected output. Until it reaches to 200 mV peak-to-peak. There. The amplitude is correct now. Now let's check the signal's frequency. If you look at here to there, is one period of the signal. It covers two divisions in horizontal direction. Each division is 50 microseconds. Together is 2 times 50 microseconds. That equals to 100 microseconds. So one period is 100 microseconds. The frequency is 1 over period. So the frequency, it is 10 kHz. Now let's turn on the DC power supply. As soon as I turn on the DC power supply, the output blue waveform shows up. Let's figure out the voltage of this output waveform. We need to count the number of blocks in vertical direction and multiply this 1 volt per division. The output waveform is not quite symmetric according to the center horizontal line. The upper portion is shorter than the lower portion. I moved the waveform upward a little bit to make it more symmetric. Now either upper or lower portion takes 3 blocks. So the peak voltage of the output waveform is 3 volt. The input signal has 100 mV and the output is 3 volt. Obviously, the output is amplified. It is stretched. If you compare the output waveform to the input waveform, we can see they are out of phase. In other words, the output waveform is the flipped version of the input waveform. This is the reason there is a negative sign in front of the amplifier's gain formula. Now I'm gonna unplug the first channel's scope probe and then place it here. We're gonna measure the voltage at this point instead. This is the actual AC signal entering to the amplifier circuit. We can see from the oscilloscope, this signal is very small. Spin the knob so the signal is more readable, and we can see there are lots of noise along the signal. I press the stop button so the waveforms are not flashing. The oscilloscope shows the peak-to-peak value of this input waveform is 42.8 mV. The expected or theoretical value should be 20 mV due to the voltage divider circuit here. The reason is 42.8 mV because there are noise. And perhaps this oscilloscope cannot detect that small signal that accurately.